Right, today we are looking at a MacBook Air logic board. The MacBook is model A1465 and the motherboard model, as you can see here on the camera, is an 820-3435 revision B, and this comes from a 2013 11-inch MacBook Air. And this comes to us as the MacBook doesn't turn on despite getting a green or orange light on the charger when plugged in, which you will hopefully see down here on this camera here. It's not the clearest of image because it's focused on the light. There you go, you'll see that now, so I can plug that in over here. So we get the light on the charger, but this MacBook doesn't turn on. So we're going to go through and see if we can find out why and see if it can be fixed, and show you how we do that. So the first thing we want to do is look over here at these power rails. These are the things that power the logic board and make sure that everything's working, so you need certain ones of these to be present at all times. These here, G3 hot, should always be present, so as soon as I've plugged this cable in, these should now be present and working. So if you can see, this one here, you can see what I'm going to be seeing on the multimeter as we make some readings, and hopefully down here on the board you'll get an idea of where I'm putting the pins, and you can see closer up through the microscope. So the first one that we need, this one's important up here. Hang on, I'm losing you. So this one here, PP bus G3 hot, that's the main one, but we don't get anything if we don't first have PP 3V42 G3 hot. We already know that we've got this because you don't get the light on the charger if you don't have this. So this is working. This one above it, PP DC in G3 hot. This is where the power comes in from the charger, so we know we've got that already, otherwise we wouldn't get this one. So the next one to check, well, let's just go and check this one just to show you that we've got this. So we search that there, and then we find out where we can find that on the motherboard, and putting it in here. And then all these numbers show all the places where that power line shows up on the motherboard. You've got this side of the board and then the other side of the board. So we're working on this side at the minute, so we can go anywhere around here to find this. And stay away from that connector. Over here, this looks like a good spot. So capacitor C4820 on pin 1, and we're going to test there. So we'll find that on the motherboard, and I'll try and show you that, get that out the way. And so we want to be down here, and which one was it? Right, second one in on this row here at the bottom. So that's going to be this one here. Okay, so I'll put one pin of me multimeter on ground and the other pin over here. There's a test point there, so we can check there. And on the multimeter you can see 3.3 3.33 volts, which is slightly low but close enough. And it's close enough, we know it's working because we've got the light. So, knowing that one's okay, we know we've got this. The next one, the most important one to check, is this one. So we're going to find where PP bus G3 hot is on the board, and we're going to check and measure that we've got 8.6 volts. So we'll copy that, paste it onto this board view. And there's several places that we can go to find that. We're over here, so let's try and find this one here. Capacitor C3080. So I'm going to look through my scope. I think I have that there. So just so that you can see it, that's going to be this one here. So one probe on ground and the other one to check that out. And on the multimeter you see 8.58 volts, so perfect, that's what we want there. And so the next one to check, we know we've got the 8.6 volts here. This one is pretty much the same. If we've got that, we've got 8.6 here and 8.6 here. So as we come down, then the next one that we are going to check is this one here. This one, the voltage we're looking for is 3 volts, and this line's called PPV RTC underscore G3 hot. So we'll copy that, put that into here so we can find where it is on the board. Okay, so several places that this one shows up, and we'll go in and check it over here. Capacitor C1910 on pin 1, which is the bottom one. So let me find that in the microscope. It's going to be there. So we are looking at, that's going to be this one here. Okay, so if I put one on ground and the other end on here and check the multimeter, we've got 0.057. So that is a problem, because if we come back to here, we need 3 volts. Okay, so we found a potential problem here, so we need to look further into that. So if I find on the schematic where this goes, or even on the board view here, if I click this pin, this will tell me all the other places that line connects to. So over here we've got 1, 2, 3, 4, 5 resistors. Up here we've got 1, 2, 3 capacitors, and this one's just a test point on the board, and it's connected to this chip U1900. So let's go on the schematic and find U1900. Okay, so this chip is powered by PP3 the 3V42 G3 hot, which we've tested for and we know we've got. Also powered by PP3V3S5. That's there on pin 2. Which one's pin 2? Let's see if we've got any voltage on pin 2. No, we don't have voltage on pin 2 either, which is another problem. Right, so I'm going to remove the power from the board and just check to see if we've got any shorts. So put the multimeter in diode mode and put the red probe onto ground and check on this pin 1. And that one is ground. And pin 2 doesn't look like it's even connected. So that's pin 2. It bothers me because that chip does need power. However, even if it gets the power, it's not going to be able to output it on this pin 1. And pin 1, if you see back on the schematics, that's where the voltage goes out for this PPV RTC. So it takes voltage in from these other power supplies, and then it puts voltage out, and we need this voltage coming out, and we're not getting it. But because we've not got all the voltage coming in, we're probably also not telling this chip to put the voltage out. But with this pin 1 being shorted, even if it was being told, it won't be able to, because the power won't go anywhere. So we've got a couple of problems. Let's see, pin 2, where does that go? Pin 2. Oh, pin 2 is not connected. Pin 2 is NC. So, okay, so when I... What does that say? This looks a little ugly to support new and old parts. Pin 5 must receive S5 power. Ah, okay. So we're not expecting anything on pin 2. Let's plug it back in. Plug power back onto the board. So let me adjust your view. And then we'll see which one, sorry, was pin 5. Okay, bottom left, or we can check it on any of these resistors. And we need there to be pin 5, pin 5, pin 5, 3.3 volts down there. Okay, there's a test point. Let's put the multimeter back in the correct mode. Okay, yeah, we get our 3.3 volts there, as expected. Okay, let's just confirm that G3 hot does come to it. So pin 13, pin 13 is going to be top right. We should see 3.3 there. I need to show you. Top right needs to be yeah, we get 3.3 there as well. So the chip is being powered as it should be. On pin 5 there, and there, yeah, and 2 is not connected. That's all correct. These other ones are they appear to all be data. So okay, so this chip should then put out voltage on pin 1, but pin 1 is shorted to ground, so we're not going to get any voltage there. So we need to track down why that is shorted. So for that we need to see pin 1 comes out and hits what? We can see here it hits C1910. Now C1910 I think was, yeah, C1910 is that one that's right beside it. Okay, so let's again remove the power from the board, go back to diode mode, where we can just confirm the resistance to ground on this capacitor. Yeah, 0.001, so that is dead short to ground. So culprits for it then could be, keep turning off your view, so culprits for this being grounded, where's the chip, there we go, are the chip itself, because as you can see from the schematic, this chip is connected to various lines and it's also connected to ground. So this means this chip has a potential to go wrong and connect pin 1 here to 7, 10, 16, 17, which are all connected to ground. Another candidate is obviously this capacitor, because it's connected on one side to pin 1 and it's connected on the other side to ground. So if that capacitor has failed, then that could short that power line to ground. So the power, instead of coming out here and going along here to these several other places like it should do, it will come out and go straight down there to ground and give 0 volts, which is what we measure. So where else could be a possibility? Well, we looked on here and we picked the line and we saw that also connected are 1, 2, 3, 4, 5 resistors. But these resistors, if we look more closely at them, this side is connected to our power line, but this side is not connected to ground on any of those resistors. So they can fail and it will not cause a short to ground. So what about these capacitors? These pin 1s, they are connected to our line, power line, and the other side, they are all connected to ground. So any one of those 3 could be our potential failure point. as well as this one, and as well as the chip. Now there's also another side to the board. I don't think there's anywhere else on this side, but if we flip the board over, there looks to be another couple of bits here. So this here is just a test point, so that doesn't do anything other than give you a place to put your multimeter. So over here then is this massive chip, U0500. Now, what is U0500? Let's have a look just by simply flipping over the board, the big chip here. It's too big really for the microscope camera, but if you check out, let me see if I can stretch that out for the minute. Yeah. So under here is the CPU, the main brain of the machine really, and it's got all this big heatsink attached to it. This comes off. This is where the fan lives, and the fan blows the air through this metal pipe, which cools it all down. That's a potential problem, and that would be a very bad problem. So how do we find out what is the problem? Let's take that back down. Oops. Take that out of the way there. And let's take... Right, we don't need the multimeter for this one. So what we are going to do is... so the chip itself looks okay. There's nothing there that gives me any reason to suspect that chip. That looks reasonable. The capacitor next to it, again, you know, it doesn't look burnt or anything like that. But if we come over here, what I see on through the scope is a little bit different to what you see on the camera, but these ones look a little bit funky. So I don't know which one, but we're going to take all three of them off and see if it clears our short. So we're going to need a little bit of flux on them. Just gently warm the board, warm the area before going in and fully heating it up to remove these. First one off. Second one off. And the third one off. Alright, so that's that's the 3 worst looking capacitors off the board, so we'll just give that a minute to cool itself down. And then I just want to check the pads of those capacitors again to see whether we've cleared our short. So let's give you back the multimeter. And again, we're in diode mode, so we put the red probe on ground and we will check, and that line is still showing the short, so none of those 3 capacitors are our problem. So what we could do, well, I'll keep them off for now. I'll put them over here for safekeeping. 1, 2, 3. Okay, so the next one then was, where are you? Yes, back to this chip, which was the U1900, and this capacitor. We'll go for him first before the chip. So again, there's a little bit of flux on him or her. Warm up the area. And then take him off. Place him down there. And again, we'll do the same check to see whether that has cleared our short. No, it has not. We are still connected to ground. So that means next up on our hit list is this U1900. We're going to take him off. And then again, there'll be a need to check pin 1 of this chip. And hopefully this will be the last one we do, and it will be the one which clears the short. Okay, that came up. So pin 1 again, that's this one here with this test point attached to it here. So and we are still showing a short. Which means the processor the Intel i5 CPU is shorted to ground. And that will be it for this board. There is yeah, there's nothing to do with that really. That would be cost effective to fix this board, which is a shame really, because you know the rest of it seemed quite a tidy piece. But there you go. So if you watched to the end, thank you for sticking with me, but I'm sorry, this board will not be solved. So I've got to call the customer now and give them the bad news on this one, I'm afraid. And well, that's the end of the video until the next one. Thank you very much.